Oh, the derivative equals 0, yeah.
The derivative of what?
S of t.
What is the derivative of s of t? No, what's it called?
S prime t.
Yes, what's it called? The derivative of position is? You've all taken physics. This is your physics teacher's about to come through the window and slap you with a trout. The derivative of position is what? Velocity. Velocity, velocity. So a particle is not moving when its velocity is 0. That's what you say when the velocity is 0. So yes, v of t is equal to s prime of t is equal to what? Negative 7 sine t. Correct. So you want to know when it's not moving, so you're doing negative sine t is equal to 0. So that's when sine of t is equal to 0. So that's when t is equal to what? Sine is 0 when it's equal to what? 0 or
1.
Pi or 2 pi or
That's it.
3 pi goes on forever. So what are the points? The position of an object is given by that. Determine all the points where the object is not moving. So it's not moving when the time is equal to any interval of pi. It's not just odd. 1, 2, 3, n pi. At n pi. N pi. Now the question though asks all the points, right? The position of determine all the points. Is that a point?
No, it's a function.
That right there is a set of x values. That's not a point because what do we not have?
A y value.
A y value, right? So the original function is, remember, s of t is equal to 2 plus 7 cosine t. So what is s of 0? That's going to be 2 plus 7 cosine of 0. What's cosine of 0? 1, so 3. So the first point is 0, comma 3. The second point, you do s of pi, and you get 2 plus 7 cosine of pi. What's cosine of pi? What's cosine of pi?
Negative 1. Negative 1.
Negative 1, so that's equal to 1. So the next one is pi, comma 1, correct? And what's sine of 2 pi? 2, well, not sine, it's going to be 7 cosine 2 pi. So what's that going to be? 2 plus 1 is 3. So this is going to oscillate. Do you see how it's going to go 3, 1, 3, 1, 3, 1? So the first set of points is 0, comma 3. And what's the next one after that? It's going to be 2 pi, comma 3. And the next one after that's going to be 4 pi, comma 3. And it goes on like that. But what's the other set of points going to be? Pi, comma 1. 3 pi, comma 1. 5 pi, comma 1. It goes on forever. So there are two types of points here. There are the even multiples of pi, and there are the odd multiples of pi. The y values are different. So how many points is the velocity 0? The velocity 0 at an infinite number of points, but there's two distinct groups of points. The first one is going to be 2n pi, comma 3, and the second one is going to be 2n, I'm using the big kid language here, comma 1. Does anybody know what does 2n mean? What does that mean? Yeah, so therefore that number is always what? Even. That represents all even numbers right there. What does 2n plus 1 represent? All odd numbers. This represents all odd numbers. So whenever it's an odd multiple of pi, it's 1. You see that up there, everybody? It's 1. But whenever it's an even multiple of pi, what is it? It's a 3. That would be the big kid way of writing it. It is not easy, I understand that, but you need to remember how to do that. Define the derivative. F prime of x is going to be what?
Negative 4
Sine x minus 1. So you want to know when that's equal to? 0. We really want to know where it's equal to 0 so we can get those different pieces of the domain. So what do you end up with? You end up with negative 4 sine x minus 1 is equal to 0. So 4 sine x is equal to negative, well, I moved the negative over too. So you have sine x is equal to negative 1/4. So x is equal to the sine inverse of negative 1/4, correct? And the thing is that a nice trig value?
No.
I don't think it is. I can't think of anything creatively in my head, so you'd have to use your... Can someone tell me what that is?
Negative 0.25268.
Yeah, and it goes on forever. It's going to be nasty, right? But there it is. So here's the thing. There's only one value though. That's kind of nice. So you have your value here. Is that radians or degrees? Probably radians. Like that. So how many regions do we have to test? Yeah, just 2 regions. To the left of that value and to the right of that value. Exactly. like this. Good. So what's a good value to the right? Better, to the right. Better than that. 0. So the derivative function is this right here, right?
No,
You
'cause
labeled
that's
it.
negative
You
0.2.
labeled 0.
What?
Yeah, you labeled.
What? No. This is the derivative value. This is the value of the derivative is 0, and that occurs when the x value is that right there. So I'm asking you, so when x is 0, what's the derivative going to be? You plug the 0 into there. What's the sign of 0?
0.
0. So this is going to be negative right there. And what should we plug into the left here? How about negative pi? Because we have trig function, right?
Yeah.
Is that correct? Negative pi, sine of negative pi, that's the same thing as sine of pi. What is sine of pi?
0.
0. And you end up with 0 minus 1 is? Interesting. So here's the thing. What do you now notice? Where is this increasing? Nowhere. And let's see if we can graphically understand that. Let's see. Look at the picture here, right? And the derivative should be positive wherever that thing is going up. Let's see if that matches. We'll zoom a little differently just so we can see if you do. If this was a calculator portion, use it, graph it, take a look at what it looks like. Absolutely. Makes a little sense, but yeah, it's getting better. That's good. The derivative of that function, right? So you have f prime of x is going to be equal to 1 over x to the 4th minus 20x cubed minus 100 times what? The derivative of what? The derivative of the inside. Good. I like it when you say that. That's right. Inside. Correct. So the derivative, I'm writing it out in 2 steps, not just doing it in 1.
Yay.
So this is going to be equal to f prime of x is going to equal 4x cubed minus 60x squared over what? The same thing, right? We don't do anything to that. Now, we're interested in where that's positive or negative, so we're really interested in where it's equal to
0.
a fraction equals 0 when what is true? So we're looking when 4x cubed minus 60x squared is equal to, what do you factor out? 4x squared, and you're left with x minus 15. So that equals 0 when x is equal to 0 or 15. So you look at the number line here, and you have 0 and 15. When you plug in x, you're looking at the output value right here. When you plug in 0, the derivative is 0, and when you plug in 15, the derivative is. We're interested in this when it's positive or negative. What's between 0 and 15 that's easy to plug in?
1.
Let's plug in 1, sure. Plug in 1. If you plug in 1, the numerator, is it positive or negative? If we plug in 1, is the numerator positive? It's negative, and if we put a 1 in the bottom, it's definitely going to be?
Negative.
So the whole thing is going to be? Positive, correct. And then what you can do to make this easy, think of it in terms of really big numbers. Really big numbers. What's a big number to the right of 15?
50 billion.
Very careful how you answer this. Can someone tell me where is it decreasing? Someone raise their hand and tell me carefully, where is it decreasing? Go.
Soft bracket.
Yep.
Negative infinity.
Yep. To
0.
to 0, yep. Soft bracket, be careful. And where is it increasing? Can someone tell me where it's increasing? Noah.
From 0
To
15.
yes. Union, not you, just you, yeah. You can say union 15 infinity, correct. Because is it increasing or decreasing at 0 and 15? Neither. It's not. It's important that you...
Wait.
That's a chain rule.
Chain rule. Chain rule. E to the 5 minus t. When you take the derivative, you do the derivative e to the 5 minus t times the derivative of this. What's the derivative of 5 minus t?
I get it.
Now, what are we interested in solving for? Where it's equal to?
0.
Again, I've told you this before, and I'm going to say it again. If you ever get stuck in a problem, find the derivative, set it equal to 0. That's what we're doing over and over again here. So if we set this equal to 0, we have 2t e to the 5 minus t minus t squared e to the 5 minus t is equal to 0. What can we factor out? T e to the 5 minus t times what? 2 minus equals 0, right? So t is equal to 0, or it's equal to?
Negative 2.
Or to 2. Is there any way, just as a careful side note here, is there any way to make this 0 right here? No. Doesn't matter what you raise e to any power, you can never make it equal 0. So the only things that make it 0 are 0 and 2. So you look at those values, 0 and 2. You have your x values, and you look at your f prime values. You know these are 0. What's in between that's easy to test? So we test 1, and we're interested in positive or negative. You have to be careful because this right here is the derivative right here. If you plug in 1, is it going to be positive or negative? Well, it's going to be 2e to the 4th minus e to the 4th. So it's going to be positive or negative. Plug in 1 into that. You get 2e to the 4th minus e to the 4th. Is that going to be positive or negative? Yeah, 2 apples minus 1 apple is 1 apple, which is going to be positive. Right. 2 things minus 1 of them is going to be positive. Now we have to plug in, let's plug in, I don't know, 5 over here. 10 of something minus 25 of something. It's going to be negative. Let's plug in something negative over here, but negative 25 minus 25 of something is going to be negative. So it goes negative, positive, negative. So where's this thing increasing?
From 0 to
0 to 2, but not inclusive, right? It's decreasing, negative infinity to 0, union to infinity. Done.
Do you put?
Go ahead.
Put it back in.
Correct. What rule are we going to use? Chain rule. So y prime is going to equal 1/2 of 25 minus x squared raised to the what power? Times what? Negative 2x. What cancels? Yeah, y prime in terms of x is going to be equal to what? Negative x over what? The square root of 25 minus x squared. That's what it comes down to. But we're interested in the rate of change at what x value? 3. So y prime at 3 is going to be negative 3 over the square root of 25 minus 9, which is negative 3 over the square root of 16, which is negative 3 over 4. So the slope there is negative 3 over 4. Does that match our picture?
Yeah.
Yeah. Is
I
it
got
negative?
Negative 0.7.
That's a pretty good estimate if you've never done this before. That's fine. So here's the exact answer, negative 3/4. The key, though, is why is this one a little more difficult than what we've looked at before? One sentence. Why?
Because there's 2 functions.
It's because it starts off with something that
It's not a function.
is not a function. I'm giving you a relation, not a function. All relations are functions, but not all functions are relations. I'm giving you something that's not a function, so it automatically makes it a little more challenging. If I just asked you, what's the rate of change when x equals 3? Why is that a slightly harder question to answer?
You don't
You don't know
know.
if
Because
positive or
there's-
negative.
You don't know if it's positive or there's 2
Yeah.
places, exactly. So in this case, it's a little bit more work. This work right here can be made a lot simpler by learning how to, the punchline of this entire thing, we're going to learn about implicit differentiation. Implicit. Yeah. Implicit.
Oh.
Yeah, it's the pen. It just doesn't catch the eye when I do it. Implicit. Is that okay now? Differentiation. I know, it's differentiation. This takes a little while to get used to, but it is not that bad. And here's the punchline. Now, let's tell you what the punchline is. It makes this process much, much quicker and much easier. You don't have to isolate anything, and it makes the math a lot easier. Why, though, do we do it, though? Why can't we just break it apart every single time? We can't because, so if we do this, if we're going to isolate f prime, where do we have to put f prime? All on one side. So we have, let's say, 3f of x squared f prime of x minus 6x f prime of x equals 6f of x minus what? 3x squared. Do you see what I did there, everybody?
Yeah.
I took this and moved it to the other side, and I took this with the 6 and moved it over to the left.
Yeah.
What can we factor out now on the left? We can now factor out f prime of x, and we end up with what? Oh, sorry, f prime times, sorry. We end up with 3 f of x squared minus what? 6x equals this thing, right? The same thing. We haven't done anything to the right. Minus 3x squared. What can we divide by now?
The 3f of x squared.
Yeah, so f prime of x is going to be equal to 6f of x minus 3x squared all over 3f of x squared minus, but again, what is f of x? F of x is what? It's y. So what do we end up with? F prime of x is equal to 6y minus 3x squared all over 3y squared minus 6x. Now here's the thing. This statement, that's in terms of x and what? X and y. So the way you write this is f prime of x and y. You're doing the derivative. You need x and y. And the reason you need that is, let's go back and look at the picture. If I just said, find me the derivative at 1, what would you say?
No.
Well, you can't. No, I'm saying, but what's the challenge with finding the derivative of 1?
There's 3 different.
There's 3 different values, right? Functions, one x value correlates to one y value. Sorry, one x value correlates to how many y values? 1. Can one x value go to more than one y values on a function? No, it can't. So if I said find the derivative at 2, that can only mean one place. But on something that isn't a function, if I said find the derivative of 1, how many places could that be?
3.
It could be 4. I mean, on this one it's 3, but could it be more than that? Sure. If you take out the vertical line test, what can a relation do? You could just go like this, back and forth to infinity, right? So you need not only the x value, but you also need the one x value and one y value describes how many points? 1 point. So here, let's go back to this. If we wanted one of these points here, all we need to do is find the x and y value and plug it into this right here. And what would we get? We'd get the slope. We'd get the slope. You need x and y value. So your homework tonight